Exercise 61, question number 2. So the question gives us two pieces of information. The first is that the sum of three terms in an arithmetic progression must be 9. So we could call A the first term, so therefore the second term will be A plus D, and the third term will be A plus 2D, where D is the common difference. And then we've also know that the product of those three terms, A plus D, and A plus 2D, equals 20.25. So we have two equations, two unknowns. We could try multiplying out this second equation, collecting together like terms in the first, and then solving those two simultaneous equations. This second one, though, would lead to quite an awkward algebraic expression to try and solve. So not an easy thing to do, but doable. You could maybe have a go at it to practice the algebra. However, we can use a nice neat little trick to do this one. Instead of doing this, we can say, if we let the first term be A minus D, because we can let it be anything we want really, start anywhere, and then A plus A plus A plus D equal 9, and then we let A minus D times A plus D equal 20.25, we'll find that in fact we get a much more straightforward set of simultaneous equations to solve. So see if you can carry on from there and work that out. I'll work through the solution below. So from 1, A plus A plus A is 3A. Minus D plus D is nothing, so we get 3A equals 9, so therefore A equals 3. So we can get A straight away, but A of course will be our middle term in this case. This is the second term. So we need to find out what D is, and then we can work out what A would be in the first term altogether. So don't forget that. And then from 2, let's multiply out those brackets. So A minus D times A. So A times A is A squared minus AD times by A plus D equals 20.25. Just take a moment to see what I've done here. I've multiplied A times A to get A squared, and then minus D times A to get minus AD in this first bracket here. And I'm going to multiply that solution by the second bracket. So now multiplying this, I get A squared times A is A cubed. A squared times D is plus A squared D. Minus AD times A is minus A squared D. Minus AT times D is minus AD squared equals 20.25. Notice here the plus A squared D and the minus A squared D cancel. So we're left with A cubed minus AD squared equals 20.25. I could take an A outside the bracket. A squared minus D squared equals 20.25. But of course we know that A equals 3. So therefore we can put that into here. We can say that therefore 3 into 3 squared is 9 minus D squared equals 20.25. So now we can divide both sides by 3. 9 minus d squared equals 20.25 divided by 3. So 9 minus d squared equals 6.75. Now, if we look at this, we want d squared on its own, and it's negative. So we've talked about this idea of if the thing we want to isolate is negative, add it to both sides to make it positive. So that's what I'm going to do here. 9 equals 6.75 plus d squared. So now subtract 6.75 from both sides, and I get 2.25 equals d squared. So d is the square root of 2.25. So d equals 1.5. So if d equals 1.5, then the first term equals 3 minus 1.5, which is 1.5. The second term will be 3, as we found, and the last term, the third term, will be 4.5. So now, as an extension activity, you could have a go at finding these 3 terms. We've got 3 terms in an arithmetic progression in this extension here. They add up together to give 21, and the product of the 3 terms is 315. So work out what those 3 terms are, and the answer turns out to be 5, 7 and 9, so you can check that.